Good morning and welcome to this last pre-hackathon training session. So this is our fifth one. We've had a month of very interesting and enlightening training sessions all along, but next week it is party time. Many things have been sent out to you all. Boxes have been shipped of provisions. You should be keeping an eye out on your mail to receive them. And let's go ahead and push forward. So today is going to be a little bit unique. You're going to actually have two different sessions that go on today. So we're actually going to go over a project. So Rich SA is actually going to do that from Omnibond, and then Charlie Day will actually go over a little bit of some data science techniques to prepare you for what you're getting into next week. But today we're going to go over, just as always, we're going to do a quick little 3-minute introduction, the hackathon objectives, deliverables and resources, and a little bit of general information, and then we'll get into those training sessions. So just a welcome from the organizers, Alexander Nolte from University of Tartu in Estonia, Amy Cannon from Omnibond, Linda Hayden from Elizabeth City State University, Boyd Wilson from Omnibond, and then myself, Jimmy Powell. Jamie, we are glad to have you here. Now, the objective of HP in the City was to originally, so pre-pandemic, we were all going to descend on Atlanta, Georgia, where the SC20 conference was to take place. And we're going to meet inside of a conference room, and we were going to bring all these minds and skill sets together inside of that room to tackle problems that directly affect the Atlanta metro or greater Georgia area. Of course, things have changed, so we're doing this virtually, but we're still looking to use those skills that comes from one of the largest supercomputer conferences in the world to target some of those issues. You should expect to gain some familiarity with data science in the cloud. Matter of fact, today you're going to learn data science directly. And last week and the previous week, you learned cloud technologies as a part of our training sessions. You're going to experience collaborative software engineering, which is going to be interesting if you've never done that before. And then you're also going to develop some professional communication skills as you present. And we have you let us know how your team is doing. Now, just to say it one more time, the deliverables that we expect from each team. So each team is going to be about so we recommend 4 students, no more than 5. We'll have to deliver these things on Monday, November 9th at 6 p.m. Eastern time. There we go. You're going to have your source code with comments in the code. You're going to have a PDF of a presentation that you all created with your team members and pictures, as well as your mentor, how you use HPC technology in your project, and then most importantly, regionally, how your project could impact the Atlanta metro area. You're going to provide us a GitHub link. So you're going to create a GitHub repository. We had a training session on that as well. And you're going to pretty up your readme.md, so your markdown file with your project description and any other information you'd like to provide. Some of the resources that are going to be available to each team include a mentor and a specialist. Of course, our Slack communications. And then through that, you can also do ad hoc video communications and talks and things. Google Cloud credits, which Boyd Wilson was nice enough to go over both last week and the previous week. Cloudy Cluster. Some of the most common languages that are used are Python, and generally speaking is used within the development environment or IDE, Jupyter Notebooks, Node.js, HTML. And then we also have some data sets that are available on hackhpc.org to help you get started a little bit. The 3 T's. So to make sure that we hit everything, teams, 4 to 5 students, no more than 5, but we recommend 4. We found that that is kind of that perfect number for teams. You're going to have 1 mentor, and then you're going to have 1 specialist that goes along with that mentor as well. So each team will have 2 people to support them directly. The time or the schedule, and this is also listed on the site, We'll start on November 5th. That night, we'll actually have team formation. We'll also have some icebreakers and surprises for you, starting at 6 p.m. Eastern time. But then on Friday, Saturday, and Sunday, we'll have 2 total group check-ins. And usually, just be aware, I like surprises. People that have been in hackathons with me before, just be aware, I like to surprise you. I like to have challenges. Some of the example topics we have range from data analysis and COVID-19, including we have a mentor that is actually a medical professional that has a problem scheduling personnel for hospitals. So that's going to be actually a really interesting thing that has come up because of the requirements of COVID-19, economic disparities, weather models, social justice, presidential election. Of course, the hackathon is starting on November 5th. On November 3rd, a very special day is happening, and we may not necessarily know what's going on by November 5th. So it may be an interesting time. Public data management, graduation rates, broadband access, insurance, public health, and the list goes on and on and on. So having said that, I'm going to step back and allow one of the team mentors and one of our veteran team mentors at that to step forward, Rich from Anubon, and he's going to give us a little bit of a walkthrough of a team that actually won SC19 last year. So he's going to give you a little bit more of a insight into what happens with these winning teams. So Rich, I hand the floor over to you.
All right, thank you, Jamie. And I'm actually going to be joined by the mentor of that team, David Reynolds, is on as well. So,
hey everybody, good morning.
Good morning.
So really quickly, because I really want to make sure that we give about data sort of in Zoom just quit. I don't know if you can still see.
We can see and hear you, Rich. Oh,
wait.
As always, Murphy has stepped in and said, hello. That's what it's kind of a little bit. Rich, are you back with us? I think he'll be back with us in a moment. So what we'll do while Rich is probably getting a good reset in. Oh, no, there we go. We see him moving. Can you hear us? He's muted. He's waving. He is. Are you back, Rich?
And I'm back.
Yes.
He is back.
That was a nice quick recovery. So what I was trying to say is we want to give Charlie plenty of time to talk about how to leverage the data sources that you're going to see and you might not have even found yet. But excuse me, the project, this is going to be a little bit of a different kind of flow. And David and I, we talked about how to present some concepts to you guys because we really want to help you visualize coming together. There's an idea, that idea might be refined because of inputs from you and or your mentor if you brought an idea. And so we want to talk about how this all kind of comes together and in a very short period of time spits out a project. So with that, let's go ahead and move forward here. So we kind of wanted to start with sort of that who, when, why, why, how, all that good stuff. So, very quickly, work with your mentors to understand what their objective is, and don't be afraid to give them inputs. Like, oh, that's a good idea, but what if we did this? Or what if we tweak this a little bit? Because, good mentors are going to be flexible and they're going to say like, oh, that sounds great, let's try it. Or, maybe they'll already know that there's a major roadblock to that and they'll help advise you on that, but at least you should be able to talk about that. So, very quickly understand what your objective is. And with that, I'll turn it over to David to kind of give an overview of what the winning project was last year and what it was all about.
Yeah, so last year the winning project was called SMS to CCQ, and coming in, I kind of had a little bit of an idea of a project that could use. Actually, Rich, could you go back one slide for me?
Oh, yep, sorry.
No worries. So yeah, I came in just trying to think of something that would be interesting and fun to work on, but then also potentially useful to other people. And so this idea was to use Twilio to develop a chat bot that would allow a user to just send text messages and receive text messages to check the status of jobs that they're running on Cloudy Cluster, or submit jobs, things of that nature. But kind of back to what Rich was saying on the previous slide, coming into that, this is just an idea. This might be a cool thing. Somebody might like to work on it, but obviously as a team, you can come in and you have your own ideas and can take it wherever you want. So as we go through the rest of the slides, we'll kind of be relating the general concepts to how this particular team implemented and worked through their different problems to finally come out with the winning project.
Cool. So, you're starting out with an idea, like David said, and you want it to be solving a problem. I posed some questions here, and as you're forming your team, you want to make sure everybody does understand what that problem is and why it's a real thing. And I kind of put in there, don't forget Atlanta. Jamie just mentioned that a few minutes ago. There's a lot of great ideas, but is it going to be something that could potentially be beneficial to Atlanta or maybe other metros in the future? So David, do you want to talk about the next one?
I can, yeah. So kind of also off of what Rich was saying, to kind of put it in perspective with the SMS to CCQ project, coming into that, it's, they're looking at, we have Cloudy Cluster and we have CCQ where you can submit your jobs and check your status, but all of that is command line based. You're tied to your computer or workstation. So looking at it, they're thinking, okay, this is cool. We can use Twilio, this third-party project, to integrate with CCQ. That's really cool and interesting. But then also it's a way that you could say, okay, if I've left the office and I remember that I forgot to start a job, or you're out on vacation and you want to get the status of a job, you can just use your phone, send a text message. So that's the part of the, will it be useful to others in addition to it being interesting? But then not just interesting. I mean, there's a lot of projects out there that would be a ton of fun to work on. It could be really interesting, but you don't want it to just be so easy that it's a breeze, you walk right through it and you don't really have to challenge yourself, because a big part of this is obviously working with others and being able to grow and learn new things off of each other. So definitely kind of balance that line between something interesting and fun that's doable, and that kind of goes into the next step of whether it can scale in your expectations, but balance that interesting aspect and being able to get it done with challenging yourself. And I'll give it back to Rich for the next one.
Yeah, and that's kind of playing on that. You don't want a project that you can finish in a few hours. It needs to be big enough to be challenging, but also realistic. We'll talk about that, but also, is it something that could have, like, this is a phase one and you accomplished it and that's great, but if you had more time, what else would you do? Could it scale to, like we talked about, maybe bigger cities, or more geographical areas? Maybe it helps Atlanta, but could it help Paris or Rome, or Shanghai, with similar kinds of things if it has to do with COVID or other types of issues? And we don't want to prescribe any ideas. We want you to keep an open mind, but think about that, when you're thinking about suggestions and when you're biting off that project scope. So, I think that kind of speaks to the expectations as well. So why don't we just go ahead and move on for time. So this one was really important because last year I started out with a team with 7 people, and the powers that be cut our team in half. And so, well, actually we ended up with 3 people because one of our 4 kind of just dropped out. And so, do you have the right mix of players? When you all kind of go towards an idea to a mentor, there might be too many of you, there might be not enough of you, but even if there's the right amount of you, find out what the skills are, because if all of you happen to be UI designers and none of you can do any sort of back-end programming, then you might have some struggles. If all of you are hardcore back-end and you don't have any UI or graphic design or web stack capabilities, then you might kind of struggle to make a presentable deliverable. So there's a balance that you need to kind of quickly form the team and there's a little bit of chaos in that beginning. And I just put this up here so you can kind of see that. You can Google 5 stages of team development to learn more about those if you haven't had that in any of your classes at this point. David, do you want to talk about the mix with the team on the winning team last year?
Yeah, I can. So especially focusing on that balance is key part. And Rich is absolutely right. You've got to make sure that you have the necessary pieces and the experience there, or the desire at least to learn these things spread out through your team so that you're capable of doing what needs to be done. But then also at the same time, you don't necessarily, and everybody's different, so it might work great one way for one team, but completely different for another. But you don't necessarily have to or want to pigeonhole yourself into, if you come into it and you say, I know everything there is to know about Python, so I'm going to do all the Python stuff, and you go do all of the UI front end stuff. That could be a great way for everybody to get their tasks done really quickly and come together in the end and have some semblance of a final project. But what leads to a much stronger team that works really well together, and I think a much more likely positive outcome, is that you cater to your experience and your strengths, but then you use those to learn from each other and build off of each other. So specifically in the winning team from last year with SMS to CCQ, we had 3 people on that team, and one of the members came in and had a ton of experience with Python, and then 2 of the members had little to no experience whatsoever. And so it would have been very easy for the one to just say, I'm going to do all the Python stuff. But the way they kind of balanced it out was the one who knew the Python, he actually went and worked with the Twilio integration, CCQ, integrating the 2 of those together, and with the messaging service that the other 2 who really didn't know anything about Python came in, and they did some quick tutorials. They learned from the other member, were able to ask him questions as they went. And so as they're building out this Python messaging server to interact with Twilio, they're getting to learn one for themselves from scratch as they went, and then off of the other member who came in with a strong knowledge of it. So at the end, they've all learned something new and built off of each other, which I think made for a really strong team and a final product.
Now, if you wouldn't mind,
yeah, go ahead.
Go ahead, guys.
If you wouldn't mind, I'd like to throw this out there as well, because this is a common question that has kind of popped up about that team formation, how they actually got together. These students didn't, well, yeah, I think I can say honestly that those students didn't know each other before they came together during the hackathon. Is that correct?
I don't think they did.
And that's kind of the norm. So one thing that I'm sure a lot of people that are both here that are new to the hackathon, as well as those that that may be watching this later because they have classes going on. In the beginning of the hackathon, there is, and they hit on this, there's a lot of interesting things going on. It's kind of crazy in the beginning, to be honest. And that's intentional. The reason for that is because everyone has that sense of anticipation, that sense of what's going on, and trying to figure out how to maneuver and how to become a group and things like that. That is an intentional part of the hackathon. The reason for that is because that makes sure and that ensures that everyone starts off on the same playing ground. After that, after your team forms, you'll begin to feel like you're a part of the team. You'll understand the project, you'll grab on, and it'll become yours. It's a process, but it's an intentional process. So if you're feeling confused and apprehensive and you're like, what's going on? Then you are right where you need to be.
Yeah, I would just say that, these stages of development, team development, not necessarily adjourning, but in the corporate world, let's say that there's a new department formed and they pulled people from all over the company to be a part of this new team. The manager or director didn't even get a chance to choose them. They were chosen for that person. Those first 4 stages may take 6 months to a year. And the hackathon, on purpose, you get like 72 hours. So to go through that entire process, and it's a little chaotic, but it really helps hone your skills of interpersonal skills, communication, workflow, everything. So kind of leading into Junie or Charlie, did one of you have a comment?
Not really. The only thing is also as far as the team members go, you do kind of need somebody who essentially becomes point man.
Mhm.
That
Absolutely.
way, nobody they can keep people from stepping on their toes. And I found out with my team at the Perk Hackathon that point man was, a, in this case, was a point woman. She was very, very vital to the team to make sure that they got their project done on time and what steps needed to be done. And she kept people from going down rabbit holes that they didn't need to go down, keeping people in scope.
I would also point out that we have these icebreakers, and the reason why we do them is to make sure that during the process of actually working, everybody has a voice and gets to use their voice and understands how to interact and how to, feel free to interject, because the teams that openly communicate end up performing better and have a stronger product in the end.
Absolutely.
And I'll also throw out there one last thing, that the teams, I think I can say just about every team that I've seen formed, excluding one over the years, has been an on-the-spot creation.
Yeah.
What happens on Thursday, or what happens opening day, the mentors come out, they do a 1 minute, 1 slide presentation of, hey, here's my idea, to capture you, to capture your thoughts. And then I basically say, all right, pick your crew. In this case, we'll have breakout rooms for each of the mentors. You'll be able to select which breakout room you want to go into. If there's any adjustments we need to make, of course, we'll assist with that. But it's all on the fly. Again, that's an intentional, chaotic element to ensure that everyone's on even playing field.
Yep. And if you're a team of 4, there's a good chance that you're going to end up in someone needing to be the tiebreaker, or making the ultimate call. You might have 2 people, and the lead or project lead or whatever you want to call that person might be on one side of that argument or decision. It doesn't have to be an argument. And so ultimately you need someone who can say, the buck stops here. We have to make a decision. This is where the way we're going to go. So yeah, great point about having someone who can lead, and your mentor can also help with that. You can use your mentor as the tiebreaker as well. So lean on everybody. There's going to be floaters who are experts, like truly experts, that are going to be available to help come in and act as consultants and help you. You're not going to be alone. And so just quickly on this slide, just wanted to talk about some of the there's a bunch of stuff out there. There's the code, the tools, the IDE that you're going to use, the data set that you're going to pull in, what APIs are you going to end up using. All of that stuff is how you're going to do it. And that's also something that you're going to need to kind of quickly figure out and decide on, so that you're not stuck on the how. You might have a rough idea, and we're going to talk about that a little bit more. But ultimately managing your time is critical. There's the daily check-ins that Jamie just talked about, and I put in here the pop-ups. Like, I was being nice. Jamie likes to sort of torture people with these surprise check-ins, and it's a good thing. It keeps you on your toes, and it makes sure that you're working.
Motivate, tomato, tomato, torture, motivate.
Exactly. So David, why don't you go ahead and lead this one?
Will do. So kind of coming off of the daily check-ins, they very much work hand in hand with kind of what I'm going to say here. And what I've seen with some of the teams that I've worked with, and especially the team that I worked with last year that ended up winning, there's a lot to be said about the plan that you come in with. And you can come in with really big goals and have this awesome idea, but you want to make sure that you don't get bogged down in that and don't get yourself hung up on it. If you come in and you say, okay, we're going to do this really cool thing, and immediately start working on that, you might get to the end and you might be really close, but can't get it working. And then you haven't really put in the effort on the core of the project. So the best way is to start with a good solid foundation, where specifically talking about the project from last year, they came in, so we're going to use Twilio, CCQ, create this chatbot. So you can come in and do your research, figure out the tools you're going to use, learn how to use those. And so for their case, that's one, probably every project coming in is familiarizing yourself with Cloudy Cluster. And so they did that. They did some CCQ stuff where they're submitting jobs, but strictly to CCQ. Then they also do the same thing with Twilio, just a little hello world Twilio chatbot, has nothing to do with Cloudy Cluster. Figure out those two on their own. And then once you've got an understanding there, they put those pieces together and you have a very basic, simple proof of concept chatbot where you can send a text, it'll submit a job, you can send a text and get status back, but that's all it is. And so from there, you have a good solid foundation, and then you can start adding some of the cooler ideas that you've thought of. And so from there, in their case, it might be adding an automated aspect where when you submit a job, it'll automatically update you throughout the day what your status of your job is. You might want to polish your UI, and in their case, come up with a more polished way of giving the information back to the user through the text messages. And as you go, you can continue to add those things. And obviously there's going to be things that you might have an idea for and you want to implement, but you just either, there's issues that you run into that just, it won't work, or you run out of time. There's going to be things like that. And a big part of the project is managing those, and kind of back to what we talked about earlier with managing expectations. But even if you get to those, if you've started with this strong foundation and build from there, you aren't going to be caught in the end where you're saying, well, we're really close, but we don't really have anything to show because we couldn't get this piece working. And that was with the SMS to CCQ. They wanted to add a database and be able to verify phone numbers and make sure that this phone number is supposed to be able to communicate with this environment and things of that nature. And they worked really hard on them, but they had some issues and they got really close. But in the end, they still had that core cool chatbot idea that they could show fully working. And then you can say, if we had a little bit more time, we would have been able to do this. We would have added this. Somebody in the future might would want to do this. And people are able to see what it does as a proof of concept and then imagine what it could do. And that works hand in hand. Those stages work hand in hand with the check-ins that you have, where you start with something simple and build from there. And I think that's a really big part of why they were successful last year.
Yep. And I think it goes a long way for the judges as they're hearing you, listening to your presentation, that you've thought out, if we had more time, this is what we would have done, or this is what we would have tried to get done. And, that shows that scalability, that it wasn't just a simple thing, but it's something that could be a much bigger project and a really cool go-to-market type of product or something. And the project last year, SMS to CCQ, their presentation was not just screenshots of the idea. It was a live demo where the phone that they were using was up on the screen, so to speak. And we could do the same thing with a Zoom meeting. So if you've got a live app that you can pull in, we could pull it in and you could share your iPhone screen or your Android screen and demo that in Zoom, and everybody will be able to watch it, and it'll be really powerful that way versus just as PowerPoint. So in conclusion, we just wanted to kind of refocus on the key elements that we've thought about in terms of not just this one hackathon, but the ones where we saw the teams that didn't work out. I can't emphasize enough the need to communicate. You need to not, as soon as you get stuck with something, do some quick searches, Stack Overflow, Google the problem that you're having, but immediately reach out to your peers, your teammates, and if they don't know, go to your mentor. If your mentor doesn't know, call in one of our floating experts or one of the Cloudy Cluster team who can help you with if it's a Cloudy Cluster or specific thing. Keep your expectations, that SMART goal thing. You want the goal to be attainable, so you want them to be realistic because you do have this time constraint. But be mindful of, the fact. I mean, when Jamie says, okay, at 5 o'clock Central Time, we're going to have a quick, presentation of, whatever. Well, all of a sudden it's 4:55, and you're like, oh my gosh, we haven't even started that. You've got to just set alarms on your phone, do whatever you have to do to kind of help yourself track your time. And are we checking the boxes on those expected deliverables and milestones? So that's it. Thanks for the the time to present this. Really quickly, does anybody have any questions? Because I know we are eating up Charlie's time. Thanks, Jocelyn.
Well, there goes my professionalism. So
she gave me a high five, so I had to give her one back.
No, clapping.
So thanks, Rich. Thanks, Dave. We appreciate your David. We appreciate you all's assistance there and kind of letting us know. So having said that, during this hackathon, many people choose to use data sets. Of course, they're important. You are able to ask the data questions, and it's able to present back information that may or may not be true, but at least you can build around it. But to give you a little bit more context and a little bit of information to go along with that, we're going to have my coworker and co-instructor and mentor, Charlie Day, to give us a little bit of information. So Charlie, I'll hand it over to you.
Awesome. Thank you. Guys hear me all right?
Yes.
Fantastic. All right, let's share my screen and desktop too. Alrighty. Okay, guys, so one of the most important aspects of these projects I've noticed is almost every project has something to do with data. But before we can even talk about what data is, we need to understand it, right? So before you say, hey, I'm going to go and import this data set, or as they were saying earlier, they're going to use a database to load information. We have to understand what that concept is. We have to actually understand what data is. All right, so put this together real quick to kind of talk about what data is and why it's important, and different ways of analyzing it and putting things in context. All right, so what is data? So this was actually, I forgot, somebody asked me to give a data science 101 talk, and the first thing I was even actually sitting down was thinking, what the heck is data? We understand it, we can figure it out, we think about it, but how do we define what it is? So I decided to ask Google, what is data? And it comes up everywhere. What is data in a computer, data in statistics, what's data mining, data on a phone? And that's really different because we have data plans now. So data is a whole bunch of stuff. Doesn't look like there is a clear definition, or at least there's not a clear question to ask, what is data, right? So Wikipedia it is. All right, so data is a set of values of subjects with respect to qualitative or quantitative variables, data, information, or knowledge, or yada, 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 interchangeably, yeah. Okay, there's one little thing that stood out to me here. It goes, data becomes information when it's viewed in context or in post-analysis. So that is actually what the key of it is, all right? It says data, aside from that, essentially what it says, data is meaningless unless we view it in context or we analyze it. So that's where the key comes into play at. We can't just randomly go find a data set and say, boom, we got a story here to tell. No, we don't, until we analyze it and until we view what the context of that data is. The context of the data is very important. In fact, a little bit of side turn here, when disinformation, right? We hear so much about disinformation now from people that should know better, right? Where is that coming from? That's coming from this. They're taking data out of context and they're not analyzing it properly, and they're coming up with a conclusion that's not correct. Okay, so we do know that data is everywhere, all right? And we do know that, what does that mean? And so where is your data? We just sit back and think about where your data is sitting at. Well, credit card company has my data, Google has my data, YouTube, of course, has my data, Facebook has my data, and they swap all the time. So when you Google something, all of a sudden you're seeing ads for it on Facebook. When you're watching YouTube videos, all of a sudden there's more suggestions on what you need to watch. Why is that? Because they're analyzing what it is you've done, and they're trying to figure out what it is you want to do, right? So what makes data important? Well, it is important because now with that information, we can target who wants what goes where, how much things are worth. But how do we understand what that is? Well, this is where data science comes into play. So what is data science? Go back to Google. Data science, actually, none of those Google things make any sense. All right. Different now, a bunch of future, overrated, fad statistics, not a science. Uh, team sport, that's probably my favorite one. But here's the thing. Data science is important because what it does is it uses scientific methods that we, as all of us have a scientific background of some sort. So it uses scientific methods, processes, algorithms, and other systems to essentially extract knowledge from that data set. So now we have two things. Data has data viewed in context. It only becomes information when it becomes analyzed, and it analyzes through data science, which is a bunch of algorithms and systems to get that knowledge and insight out of that data set. All right. So hopefully you guys are still with me here. So basically, data science is the ability to understand that there is a story that your data set is trying to tell. So the behind the data science is trying to extract that story. Now, there are many ways to extract the story. Right now, the biggest thing that we always hear about is machine learning as a way of extracting data, as extracting a story. And we'll get into that here in just a bit. But why is that important to us? Okay, so data science 101. Why is there a story? Why do we want to use data science? Because data science solves us problems, and those problems are usually money related. Like, for example, Southwest Airlines realized that if by reducing the amount of time that their planes sat on the tarmac, they're saving $100 million a year. And I'm sure that they're figured out some other story now in 2020. UPS, they just started making right turns instead of left, and they were saving 39 million gallons in gas, and that's a big one. TAC realized that so those of you guys, I'm sure you guys know who TAC is. We have a bunch of awesome supercomputers, a bunch of HPC resources. Every time whenever our machines are sitting idle, it costs us $32,000, right? So our job is to make sure that people are using our machines all the time. So data is worth money. So now we have data viewed in context, gives us information. If we analyze that information, we could find a story, and that story, if we analyze the story properly, it's worth money. Okay, so this is where big data comes from. There's no real definition of big data. If you Google big data, you're going to come up with thousands of different hits because nobody really knows what it is because it's big. All right. I mean, it's bigger than we can imagine. You know, when we step back and think about what the universe is like and how it's growing, it just blows our mind. That's what big data is about. There's so much information out there that that isn't readily available for us to look at. We can't actually see it, so we can't actually understand what the scope of it is. Okay. But we are kind of in the era of big data, or we have a data-driven world. And things that are needed to get there is scale, speed, and ubiquity. All right. Scale is actually pretty easy to think about. Essentially means I need to be able to carry my data with me and sit and take it where places. Amazingly enough, data wasn't really scalable until about the late 1800s. Before that, data was, well, best where I look at data was set in books and these giant piles of books, or in somebody's head, or on a cave wall, right? We've been collecting data since the caveman days. Cavemen drawing on a cave wall, they're securing a story of, you know, awesome hunt that went really well or an awesome hunt that did not go well, right? Egyptians took their data and they carved it in their walls of their pyramids and their homes or whatever. That's data. When the punch card was invented, that gave us a huge new era because now we could take our data with us. You know, I could take all the information I have and I could stick it in a briefcase or a suitcase or, you know, an airplane and take it somewhere else and have somebody else visualize what my data looks like. All right, but problem was scalability. Yeah, okay, so yeah, we got this stuff, but you know, it can only scale so far before it becomes a ridiculous amount of data. Now though, you know, I just got my younger kid a NVMe drive, right? It's 1 terabyte and it's the size of, you know, a memory square, right? About yay big, and it's really quick. So now scalability is not a problem anymore. So now that we can take data, we've come across, or take data, scale it up as much as we need to, we've got this revolution going on. Speed, also important. Second prong of big data revolution comes with speed. How fast can we move this data around? How fast can we compute with it? How fast can we analyze it? You know, and well, that is increasing amazingly, especially with, you know, some of the stuff that we have over at TAC. And ubiquity. This is a weird one because for data to be important and data to be analyzed quickly, it has to be accessible. So essentially, that's what ubiquity means. It has to be available, has to be there for us to be able to analyze. All right. So in a nutshell, we have we're going to have to try and put the science in what data science is. The short answer to that is there's billions and billions and billions of data points that we have collected. What are we going to do with it? We understand that data is there. It exists. It's got something valuable in it. But what's all that mean? Okay, what's going on? What can we learn from it? Whatever. That's where data analysis comes into play at. And this is where essentially what you guys have to do with these data sets that you download. You have to analyze it and figure out what is the story that's underneath it all. But here's the catch. You have to understand how the data came to be able to process it, to analyze what the story is. And that is the catch, understanding how the data came to be. A great example is the other day, somebody made a comment, you know, at some big event that 85% of the people who wear masks get COVID. That wasn't the story behind the data set. That was just a little side note that, hey, if you go to restaurants and are in closed areas, even if you're wearing a mask, it's not going to do you much good. That was the story, but that's not what that was. But it was misinterpreted because whoever put that story out there didn't understand how the data came to be. All right. So where we move from here? Well, how do we understand what the data analysis is? We experiment. Okay, so experimentation has been around a long, long time. Unfortunately, experimentation takes a long, long time to actually analyze and build a good data set. All right, we need experimentation. I'm not saying experimentation is bad, but for our hackathon, we don't have time to do an experiment. Okay, so this, and honestly, we also don't have the time to do machine learning, but machine learning is what is slowly taking the place or adding to experimentation. And for you guys to understand, I know you're going to want to bite that machine learning, you know, bait, because it's there, it's cool, people have all heard about it, and you're going to sit there going, oh wow, I got this awesome data set, I'm going to put some sort of machine learning algorithm and do it. There's not enough time, but I want you guys to understand what machine learning is. It's not a magic bullet, and it comes in a bunch of different flavors. All right, so there is supervised learning. Supervised learning essentially is you're trying to predict something that you've seen before. All right, so we know what a usual outcome is, and we're going to change the set around and see what the new outcome is going to be. We start out by putting the exact same, we run an experiment, we get a result. Now we're going to simulate that experiment with the same data and see if we get the same result from our experiment. If we do, we're supervising the entire analysis and we're seeing, it works. Now we can feed it different information and get different results instead of having to run the experiment. Essentially, that's what supervised learning is about. You try and analyze the outcome of a process, which was in the past, build a system, and try and draw what matters and build predictions for the next time it happens. Then we have unsupervised learning. All right. With unsupervised learning, what we have is we work without an observed outcome or target. So we don't know what the result's going to be, but we know we can make predictions to understand what the result could be. All right. So it's less concerned about making predictions and more about identifying relationships or associations, all right, that exist within the data. So here's like the suggested new friends feature on Facebook. All right, this, hey, you might know this person because these groups, these points here exist with this person, and this points here exist with this person. You probably know each other. All right, and then reinforcement learning. That's the other type of machine learning. That's what you kind of see with those automated video games that get played. All right, you know, with all of a sudden you see when they had a AI try and play Super Mario Brothers, and you're just watching this things that Super Mario does that you wouldn't do when you're playing the game, but for some reason the machine figured out that's the best way of playing it. That's reinforcement learning. It's like the 2-year-old who keeps running into the table until he learns to duck, right? Okay. So, and then there's AI. AI and machine learning are a little bit different. AI is all about that human emotion that you're trying to get from a data set, that insight, that the human intuition bit from a data set that you're trying to grab. That's what AI is all about. Is all about the insight. Okay, so in a nutshell, data is important. We need to understand what the data is for it to become important. We need to know where the data came from and how it came from. And we're trying to find out what the underlying story is through data science. Okay, so we have about 10 minutes left here. When it comes to data sets, there are lots of data sets available. If I Google Austin Open Data, I'm in Austin, Texas, I come to the Austin Open Data portal. And there, since we're going to be doing stuff about Atlanta, if you Google Atlanta Open Data, you're going to find a lot of data sets about Atlanta. And it's actually kind of cool when I actually did go to Atlanta, and there's they have an open data set here. One of the coolest things I saw was, hey, look, story maps. Tell stories about local issues and solutions through data sets. So, they've got a lot of information already here. All right, so let's go back to the Austin data. And there is one in particular, because we live in Austin, and the biggest issues that we have to deal with, biggest issues we have to deal with on a day-to-day basis before all this happened was traffic. All right, traffic in Austin is horrible. And well, okay, so there's a story there. Let's see what that story is. Well, hey, look, there's transportation. And you'll see, hey, there's real-time traffic incidents reports. We can download that. I actually already did. And you can download it and we can look at what it is. And it comes into a CSV file. All right, and if you look at the CSV file, there is information there. I can definitely see there's information. Scrolling through here, it is absolutely meaningless to me. I don't understand what this is or what it's saying. I see bits and pieces of addresses. I see bits and pieces what might be longitude, latitude, but aside from that, doesn't make any sense. So what we have to do is use the tools we have to be able to analyze what the story behind this data is. And I hope, let me clear all this output here. Okay, so Jupyter Notebooks are fantastic to give us instant information and give us a quick idea of what we're trying to look at. All right, so this is all Python. Python has a bunch of cool stuff available to us. It's got pandas, NumPy, pandas for data analysis stuff, NumPy for numerical analysis stuff, and then Matplotlib to actually view things. All right, so first thing is I'm going to read in the data set. Pandas, I imported as PD. Pandas, I'll read it CSV. It's a CSV file. It's comma delimited. I can read it in and put it in this nice little data set that Pandas gives for me. So we're going to read in the data set, and now we're going to look at what that data set is. All right, so now things are making a bit more sense to me. There's a traffic ID, there's a date it was published, what was reported, and a location. Okay, this is kind of cool. This gives me some interesting information. I can scroll through here and try and make sense of it all, but there are some, there's a whole lot of information there that I'm not going to be able to see. It's just numbers. All right, so there's a latitude and a longitude. What happens if I plot that? Okay, let's plot latitude, longitude, and see what comes up. Nothing. I got dots, and there's no information once again here. So obviously what this is telling me, since it's longitude, latitude, and I'm seeing there's cluster here, cluster there, there's probably some inconsistencies. So let's see if we can narrow that information down. Let's just look at crash urgent. Now it's kind of interesting the way there's a bunch of different ways to query a data frame that we built here. I can just do a bunch of, all right, just give me all the stuff where this issue reported is equal to crash urgent. And how do I know that? Well, I was scrolling through here and I saw there's, crash urgent, there's traffic hazard and crash service and whatnot. Let's just look at crash urgent. see if we find a story. Doing it this way, it gives us a data frame that is bunch of trues and falses. All right, so I can just tell me to look at what's true and what's false. So let's just look at what's true and what's false. So now I get all these crash urgents that are just crash urgent by doing that little query up there, and see if that has narrowed it down enough for me to graph. And it hasn't. I still have these little dots and there's still no story. So we can keep querying down. This is where it comes into play that I have a little bit of context of this data set. I know it's Austin, Texas. I know what Austin, Texas' longitude and latitude is, right? So I can do just the latitude and the longitude of Austin and the surrounding bits and narrow our data set down. Now we have some more information. Hey, this is looking more like a data set. It's all kind of clustered together, so I can't view it. But we can modify our graph, modify our plot to make it a little smaller. Hey, there is something coming up. Let's make it a bit bigger. Making it a bit bigger, what we're seeing is a map of Austin, Texas. Obviously, we see this is downtown. All right, we can see some big roads. Mind you, these are every place in Austin that's got a traffic accident or a collision. If you map out all the collisions in Austin and you get a map of Austin, there's a story there. It's telling you that Austin traffic is kind of bad. All right, before we continue, I'm just going to show you a couple more things we can do. There is a better way of querying data. There's this thing called a Lambda function. Lambda functions are awesome. They're anonymous functions. Essentially what you do is you build a function that just templates what the function is going to look like. And then you can modify the function as you need to. So here I created this query function. It's and all I'm doing is looking at reported issues. So I can send that query function different types of reports, either crash urgent or collision, and see what that comes up with. So now I have these queries defined. And now with those queries defined, I can just graph crash urgent as one color, in this case blue, and collisions as red, and we'll see what we get in our data set. So there is our map of Austin, Texas. We see everything that is considered a collision in red, everything that is an urgent crash in blue, and essentially we have our little map of Texas. This is cool, or map of Austin. This is cool in a couple of reasons. A, it shows us what roads are bad. We can also, I bet, query through this data set and see when it was reported, what time it was reported. So we can see, hey, when is it bad to drive around in Austin? When is it safe to drive around in Austin? What road should I take? What road shouldn't I take? And what routes can I avoid? What routes can I take? What routes are safer by looking at this map and understanding our data? But we couldn't get to this point until we understood what the data set was, what the context of the data was, and what the context of and what some insight of Austin data looks like. So we have to have all those things in play before we get even to a point where there's a story that's beginning to be told. All right. So that's the kind of the point I was trying to make here is, yeah, there's data sets out there, but until you kind of analyze it and clean it up and have some insight knowledge on how to clean it up, it's not going to make any sense. Because before we were here, nothing, just blobs. Now we have a little bit better understanding of what our data set's trying to tell us. So yeah, that was the point of this little demo. Are there any questions on here or about this?
Yes,
And
Charlie, I got lost.
right on time.
I got lost when you said the word data. No, I'm just playing.
What is data?
Everything is data.
I forgot there's even even next generation pulling a different definition of data. So
So Charlie, I do want to make sure that this Jupyter notebook and your slides will be available later. Is that correct?
Yeah, I'll push that into my GitHub repo. Or do you want, or is there a HPC in the city GitHub repo
There's
you want this in?
HPC in the city. Just send me the copy and we will get it up on the site. Actually, Josh will get it up on the site because, you know,
Will do.
peanuts. We sorry, it's not an inside joke, but it is, you know, he gets paid. Oh, that's right. That's right. No peanuts. I forgot. We cut that off. Charlie, thank you so much. Thank you so much for your presentation. We're going to open it up for questions here in a moment, but I do want to end at 10 o'clock so that we can, just in case people have to run. Thank you again, Charlie. Thank you again, Rich. I'm just going to share this screen for a moment so that everyone has their contact information. So to finish out the video, just want to thank again Charlie and Rich for their time and giving us the information on both how a project goes from beginning to end, and with Rich, also David assisting him, and Charlie for giving us a really good understanding of data science, and then the bonus of that amazing Jupyter notebook where we're able to see how a data set actually tells a story about how traffic here in Austin is horrible. But having said that, I'm going to go ahead and end the video for right now. Although please stay on to ask any questions. And for those that are watching this later, just want to remind you, next week, November 5th at 6 p.m. Eastern, 5 p.m. Central, and 3 p.m. I hope I did all those correctly, Pacific time. It'll be on and popping. We're looking forward to seeing you. And beyond that, take care.